One of the important things when we talk about radioactivity is we have to determine how long a material is going to be radioactive. This is an especially important question for things like nuclear reactors or in medical applications where they're going to use radioactive isotopes to, say, track things in your body. It's very important to know how long is this material going to be radioactive. The way that we measure that is called the half-life of a radioisotope. Okay, so the half-life is the amount of time that it takes for a sample to basically radioactive decay half of its material. Okay. So half-lives serve many purposes. Medicine, your book devotes an entire section to half-life use of radioactive materials. I will not be testing on any of those specifically, but it's really interesting stuff, especially if you have a family member who's ever gone through any type of those procedures. It's really interesting stuff. I would encourage you guys to take a look at it, especially those of you who are going into nursing, which is a lot of you taking this course. So definitely worth looking at. Also, dating materials. That's not, going out on dates with people. That is carbon dating. So looking at year dates, how old are materials. Dating materials that works with carbon-14, that isotope. So knowing how much of a sample has decayed can estimate how old things are. For us, what we're going to be focusing on is looking at how many half-lives have passed and how much material has passed, or how much material is radioactively decayed. So if we look at an example here, we have Krypton-79, and it has a half-life of 35 hours. How many half-lives have passed after 105 hours? In this class, we're always going to be dealing with whole half-lives. Okay, we're not going to split a half-life in a fraction or anything like that. So basically, we have to figure out how many times 35 hours goes into 105. Okay, so the easy way to do that is to just add them up. So let's say we have 2 half-lives. So we have 35 plus 35. That's going to be 70 hours. And we're still not up to our 105. So we'll add another half-life. And we get to our 105 hours. Okay. So we get 3 half-lives. And I just shorthand half-lives HL. And that's just me personally. That's not necessarily a standard. So fairly simple. Okay, I'm not wanting to throw any tricks here. The math here is this simple, so don't make this more complicated than it really needs to be. Okay. Next question, if we start out with 75 grams of Krypton-79, okay, how much mass, how much material has remained after the 105 hours? Okay, so basically we have 3 half-lives that have passed, so this mass is going to reduce in half 3 times. Okay, so we can't take 3 times 2 and then divide that. Okay, that's not how this works. We have to divide this in half 3 different times. Okay. And that's all we're ever going to do with half-lives. We're just going to divide by 2. Okay. So if we take 1 half-life, okay, we're going to divide by 2. So 75 divided by 2, we have 37.5 grams of material left after 1 half-life. When we divide by 2 again, so this is our second half-life, we're going to divide by 2. What do we have? 18.75. So after 2 half-lives, we have 18.75 grams of material remaining. Then for our third half-life, again, we're dividing by 2. we get 9.375. Which really our sig figs are now kind of getting a little out of control. So really this is 9.4 grams. So that's how much material is going to remain after 3 half-lives, so after 105 hours. So that's all there is to half-lives. Again, please don't make this more difficult than it needs to be. Okay, for the determining how many half-lives, you're just figuring out, adding them together. Again, I'm not going to say give you, how many half-lives have passed in 17 hours. Okay, I'm going to always be dealing with whole half-lives, and that means that we're always only going to be dividing by 2. And we're not going to be dividing by some sort of fraction. The math in between half-lives is very complicated. So we're just going to deal with dividing by 2, however many half-lives you have. QMP for you to help to practice these, as well as the sapling site. And in the next video, videos, you're going to watch a TED video on nuclear reactors. And then I'll show you the math that we'll be talking about and will be more similar to exam questions.